Hello, children. Good evening.
Good evening. Good evening.
Yeah, 1 minute. I'm just open tab. Yeah, last class, where did we stop, children? Last class, where did we stop?
Ma'am, we finished 1.3.
We finished 1.3, is it?
You gave some homework and yeah, I did it.
Okay, so we will go to 1.4. So before we go to 1.4, I have to teach you one thing. No? Yeah. Hold on, I'll just share the PPT. Yeah, did you people solve the homework?
Yes, ma'am.
Okay. Yeah. Now, before we go to 1.4, we have three small theorems. Only statements are important here. All the three theorems, first let me explain one thing to you, then we will go to the statements of all the three theorems. Okay? Only the statements are important in this. The first thing is, now you know about the decimals, that is terminating decimals, non-terminating decimals, recurring decimals, non-recurring decimals, all these things you have heard, right? So let us see examples for all these three. So if I say 4.12, so I'm stopping the decimal here. I'm telling 4.12 and I'm stopping it. So it means this decimal is a recurring decimal. This decimal is a terminating decimal, correct? So this is a terminating decimal. So what do we call it? It is a terminating decimal. Okay, yes. Next. Now, if I write 2 by 3, so 2 by 3, the value of 2 by 3 will be 0.66666. It goes on, correct?
Yes,
So this is
ma'am.
non-terminating decimal, you can say, or you can just say it is a non-terminating decimal. And what is happening to the value 6? The number 6 is repeating, correct? So it is a non-terminating recurring decimal, we say, or repeating decimal, recurring or repeating decimal we call, correct? We know this, right? Yes, so this is a non-terminating recurring decimal. Okay, fine. Then what about this number? This is actually the value of pi. 5, which is equal to 22/7. This, we actually stop it at 3.14. It doesn't stop there. If you start doing the division, it will not stop at all. You will be doing the decimal continuously. But do you remember life of 5? He keeps writing the value of 5 value, correct? Keeps writing the value of this. Yeah, so it is a non-terminating decimal. And is there anything which is repeating here? No. When I say repeating means after every interval, the same number should repeat. Now, suppose if you have 174, like this, if you have, now this 174 is what is happening to 174 here? It is repeating, correct? After every 174, there is again 174 which is repeating. But if you see the value of pi, that is 22/7, when you divide, it will not happen. It will not repeat like that. Okay? Then this type of decimals, we call them non-terminating because there is no end for it, correct? Non-terminating and non-recurring decimals, these are. Okay, these are non-terminating and non-recurring decimals. So any decimal which is in the form of a terminating decimal or non-terminating recurring decimal, both of these can be written as rational numbers. So these two are rational numbers. Okay, but if you come across a decimal or if you come across a fraction which is in the form of p/q and the decimal form of that is non-terminating, this is a non-terminating, right? Non-terminating, and it is non-recurring also, right? So if you get a non-terminating, non-recurring decimal, then that type of decimals are called irrational numbers. Understood? What do you mean by irrational? Till now, in our lower classes, we were just telling what do you mean by irrational numbers? The numbers which cannot be expressed in the form of p/q, where q is not equal to 0 and p and q are co-primes. That is what we used to tell before. What is the meaning of irrational? If you write in the form of p/q, like 22/7, now you can say, ma'am, this is in the form of p/q and 22 and 7 are co-primes. Yes, correct. But then if I have to say that this value is irrational, then why is this called irrational? Because it is the decimal form of this is non-terminating and non-recurring decimal. Okay, the decimal form of this is non-terminating and non-recurring. Therefore, we call this irrational number. Understood? This is what you have in the 3 statements. So now let us go to the 3 statements, the 3 theorems. Theorem 5.1, what does it say? It says, let x be a rational number whose decimal expansion terminates. Whose decimal expansion terminates. Then x can be expressed in the form of p/q, where p and q are co-prime, and the prime factorization of q and prime factorization of q is of the form 2 raised to n and 5 raised to m, where n and m are non-negative integers. Okay. Now, till here we have understood. till here we have understood from the first three examples, correct? What is it? Let x be a rational number whose decimal expansion terminates. So you can take this example. The decimal expansion is terminated. Or if I say 5 by 2, how much is 5 by 2? Decimal expansion of 5 by 2.
2.5.
2.5. Yes,
0.5?
ma'am.
Yes. So it is 2.5. So it is a terminating decimal, correct?
Yes,
Now, if
ma'am.
I ask you 1.5, I'm sorry, my daughter just pushed my hand. So if I say 1.5 and ask you whether it is an rational number or an irrational number, you know. Why? It is a terminating decimal, correct? Now, what does the statement say? Let x be a rational number whose decimal expansion terminates. Yes, decimal expansion is terminating. So x is a rational number, we said. Then x can be expressed in the form of p by q. So x can be written in the form of p by q, right? So 1.5, if I say, then I can write it in the form of 3 by 2, correct? Where what are 3 and 2? P and q. And this 3 and 2 are co-primes, correct? Yes or no?
Yes,
They
ma'am.
don't have any common factors other than 1. So we can say that till here the statement is understood. Now, the next thing in the statement is the prime factorization of q is in the form of 2 raised to n and 5 raised to m, where n and m are non-negative integers. So what do you mean by non-negative integers? There's nothing but positive integers. Instead of telling it as positive integers directly, they have given it as non-negative integers. All the other integers which are not negative, other than negative integers, they are called non-negative integers. Okay? Understood? Now, so first part we have proved. Now let us see the second part. So second part, if you see, the prime factorization of q. Now what is the value of q in this ratio? 2, right? So the prime factorization of q should be in the form of this. So I can write 2 can be written as 2 raised to 1, correct? Into 5 raised to 0 I will take. If I take 5 raised to 0, so how much is 5 raised to 0?
1.
1. Correct. So 5 raised to 0 is 1. So can I write this expression like this? 3 divided by 2 raised to 1 into 5 raised to 0.
Yes, ma'am.
We can write it like this, right? The value does not change. So I can write this 5 raised to 0 on top also. The value does not change because the value is 1. We are multiplying it with 1. So therefore the value remains same. So now what we did? X is an irrational number, right? X is an irrational number whose decimal expansion is a terminating value. It is terminated. Then x can be expressed in terms of p by q, where p and q are co-primes, correct? Then what we did? We saw what is the prime factorization of q value. So prime factorization of q value is in the form of 2 raised to n and into 5 raised to m, where n and m are positive integers. Got it? Therefore, we can say finally we can prove that, or we have proved that x is a rational number. Understood this? Understood the statement? Is it clear?
Yes.
Hmm? Okay.
Yes,
So
ma'am.
any fraction which is given to you, if you get a decimal expansion of that in the form which is a terminating decimal, then we can call it rational number. Okay, now suppose we have 3 by 8. Okay, so now they have given 3 by 8. So let us write 3 divided by denominator has to be written in the form of this, this one, 2 raised to n, 5 raised to m.
So it will be 2 raised to 3 into 5 raised to 0.
2 raised to 3 into 5 raised to
0.
0. Right? So now since we have expanded this in the form of P by Q, where Q is 2 raised to n and 5 raised to m, we can say that this is a rational number. Understood? Clear, right? Okay.
Yes.
You want to write it down?
I wrote, ma'am.
Prati and Shreya, you want to write?
I wrote now.
Finished.
Finished. Very good. Okay. So we'll go to the next statement. The next statement, it says, let x is equal to p by q be a rational number such that the prime factorization of q is in the form of 2 raised to n, 5 raised to m, where n and m are non-negative integers. Then x has a decimal expansion which terminates. So they are telling just ulta of whatever we have studied in the first statement. Correct? It's exactly the opposite way they have told. So there they told x is the rational number whose decimal expansion is terminating. Here they are telling x is equal to p by q, which is a rational number. Okay? Understood this? It's the same thing. And then the next statement says, let x equal to p by q, where p and q are co-primes, will be a rational number such that the prime factorization of q is in the form of 2 raised to n, 5 raised to m. Then x has a decimal expansion which is non-recurring, non-terminating and repeating. It is recurring. Like, for example, I gave you, what is that? Yeah, if you do 1 by 3. Now 1 by 3 is x is equal to 1 by 3 they have given. Now this is in the form of p by q, correct? This is in the form of p by q. When I'm explaining, stop writing, children. I'll give you time to write if you want. Okay? I want you to understand first. Then you can write how much ever you want. Yeah. So now 1 by 3 is in the form of p by q, where the condition says p and q are co-primes. 1 and 3. Are they co-primes?
Yes.
Co-prime means they should not have
Yes,
any
ma'am.
common factor other than 1. Yes, they are co-primes. 1 and 3 are co-primes. Correct. Then the prime factorization of q should be in the form of 2 raised to n, 5 raised to m. Now, is this in the form of 2 raised to n and 5 raised to n?
Have to do q is not in the form of 2 into n.
Hmm. So 1 by 3 is not a rational number. Okay. Now let us take another example. Let us take the example from the textbook. Hold on. Yes. Why is the textbook not opening? Huh. Huh. Not this. Yeah, here only I was right. Yeah. So let us take the example 1 by 7. Okay. It is a non-terminating decimal, non-terminating recurring decimal. Then it is called and then it is called a rational number. Understood? Or 2 by 3. What we took before? 2 by 3 is equal to 0.6666. It goes on. So how do we write this recurring decimals? We write 0.66 and then we write a bar on top. So it means it is recurring. Okay.
Okay, ma'am.
Okay. So now let's go to the exercise questions. So the first question here is, without actually performing the long division, state whether the following rational numbers will be a terminating decimal expansion or a non-terminating repeating decimal expansion. Okay. Whether it is terminating or non-terminating, we have to tell. Right? Yeah. Now the first one is 13 by 3125. So let us just take the LCM of the denominator. 3125.
Ma'am, it's
Yes.
5 power 5,
Yeah.
like 5 raised to 5.
Yeah, let's see. 5 how much, sir?
625.
625. Okay, fine. 625. Then again 5 125. Then again 5 25. 5 5. Sir. So how many times? We have 5 times 5. So I can write 13 is equal to 5 raised to 5 into 2 raised to 0. Correct? 2 raised to 0 and 5 raised to 5. Correct?
Yes, ma'am.
Then what is asked? Yes, they have told. Yeah, we have to show whether it is now.
It's
Hmm.
it's terminating or not terminating. It is
Yeah.
terminating because it is into
Yeah, without
like
doing the decimal expansion, you have to show whether the given value is terminating or non-terminating. Correct? Yeah. So now what do we write is? So the conclusion, how can you write?
uh
So since the
like
denominator is in the form of, you'll write the denominator is in the form of Denominator is in the form of 2 raised to n, 5 raised to m, 2 raised to n and 5 raised to m. The decimal expansion is terminating. The decimal expansion is terminating. Directly, if you write this, it's enough. Okay?
Yes, ma'am.
So you don't have to do the division for this. Directly, we can tell.
Ma'am, even the next one is terminating.
Yeah, next one we can directly say. So 8 is
Yes, ma'am.
nothing but 2 raised to 3. Correct? So that is also terminating. Next, 455. 455. Let us take the prime factors of 455. So let's go to, I'll erase this first question, whatever I've written. Okay. Now the third question. This is 64 divided by 455. So let us do the LCM of 455. Prime factorization. So from 5, if you do, 9s are 45, 5 ones are correct. Then 7, 7 13s are.
7, yes, ma'am.
So we got 455 is equal to 5 into 7 into 13. So now 5 into 7 into 13 we got. It is not in the form of 2 raised to m into 5 raised to m. It is not in the form of this, correct?
Yes, ma'am.
Therefore, it is not terminating. Okay? Got it?
Yes.
Okay, fine. Next, 1600. Now find out 1600. Next one, question number
I
4
got it, ma'am.
is 15 by 1600. Yeah, from 5 if I do, or 2 let us do. 2 8s are 16, so 0 0 we can write directly. Then again 2 4s are 8, 2 2s are 4, 2 10s are 20, correct? Then you have 2 5s are 10. Then again 2 how much are
25.
2 25s are, yes, again from 5 we have to do. So 5 5s are. So we got 1 2 3 4 5
It's
6
2 to the
6
power
times.
6.
So is equal to 2 raised to 6 into 5 raised to 2. So it is already in the form of 2 raised to n, 5 raised to m. Therefore, it is a terminating decimal. Okay, it has terminating decimal.
Fifth one, we can directly tell it's non-terminating.
Yes,
And
because
7's cube.
7 cube is for 343. So we can directly tell this. Fifth one. Okay. The next question, it is here. Question number 6 and 7. So question number 6, it's already given to you. It is a terminating decimal. It has a terminating decimal, correct? Question number 7,
It is not.
it is not, because 7 raised to 5 you have. If this is not there, then it is a terminating decimal. Okay?
The eighth one is
15 one?
terminating.
15.
Yes, ma'am, you can simplify it and then do it.
They have told you specifically without doing division. Right? They're specified without doing division, you have to tell whether it is a terminating decimal or not terminating. Okay. Why did I write 3 here? 6 by 15. So 15. What are the factors for 15?
5
Into
3s are.
three.
Or you can just simplify it like this. 3 2s are 6 and 3
That is
5s
what I
are.
told, ma'am.
Okay, okay. This is fine. 2 by 5, if you take, you know it is a recurring decimal. I mean, it is a terminating decimal. Correct? Because 5 is in the form of 5 raised to 1, 2 raised to 0. Denominator. Next one, 35 and 50. 35 and 50 also, if you simplify, it becomes 7 by 10.
Yes, ma'am, it is terminating.
Now 10 is in the form of 2 raised to n and 5 raised to m. 5 into 2. Next one, 77 divided by 210.
Non-terminating.
It is terminated? Non-terminating.
No.
No, ma'am, non-terminating.
Non-terminating, correct. Okay. So we solved the first exercise, I mean, first main. Okay, understood this? So which are
Can you
not
show the theorem slide?
theorem statement? Okay, 1 minute. So here, question number 10 is non-terminating. Question number 7 is non-terminating, correct? And question number 5, 3. So these are the terms which are non-terminating, correct? Okay. Remember this. For the next question, we need these things.
Yes, ma'am.
Which statement you
We
want?
have to prove it.
Yeah. Which statement you want, Smriti?
1.7.
1.5. Yeah, here it is.
1.7.
7. The 7 is here. If you want, if people can take screenshots and then write later also. Anything is fine. But I prefer you people writing in the class. Writing in class is good. At least numerical problems, whatever we solve, I want you to solve it right away in the class. Okay? Don't take screenshots for that.
Ma'am, we should do the second question right here, the division part.
Mm-hmm.
Ma'am, the
I didn't get
second
you.
question in the division part where we have to prove it was terminating
Yeah.
or not.
No,
So
we don't have to do the
we sh-
division. Without doing the division, you have to do it.
No, in the second part, the second question.
Yeah, in the second part also, without doing division only, you should do it. I'll tell you how to do.
Okay, ma'am.
This is done, Smriti?
Yes.
Okay. Now, in the second question, they have told, write down the decimal expansions whose of those rational numbers in question 1 above which have terminating decimal expansions. So we should eliminate 10, 7, 3 and 5 because they are non-terminating. All the others are terminating, correct? So let us take question 1, that is 13 by 3125. Question 1. 13 divided by 3125. Now we have to prove that this is a terminating decimal. So now we know this. This is equal to 13 divided by 5 raised to 5. We know this already. Correct? Now, if you have to write it in the form of 2 raised to n and 5 raised to m, what I will do is 13 is there. Here in the denominator, we have 5 raised to 5. So I will take 2 raised to 5 and the same thing will be multiplied in the numerator also. So if you do same multiplication in numerator and denominator, the value is not changed. Value remains same. Okay. So we have not violated the mathematical rule. So this will be equal to, now how much is this? 2 raised to 5. How much is 2 raised to 5? 2 cube is 8. 8 into 2 is
32.
16. Yes, 32. So what we have to do is 13 into 32 divided by, now how much is the denominator? Don't cancel again. See, denominator, we have same exponent, different base. Correct? So same exponent, different base means we can directly write 5 into 2 whole raised to 5. We can write it this way, right? Remember?
Yes, ma'am.
So we have written this a into b whole raised to m will be written as a raised to m into b raised to m. Correct? You remember this identity? The same identity we are using here in the reverse order. RHS is given, we have written the LHS. That's it. Yeah. Now just multiply this numerator and tell me how much you get. This is 10 raised to 5. What is the numerator? You have to tell me.
One second. Yeah, ma'am. It's 416.
How much?
416.
416. Okay. So it is 416. So now your answer is finished. See, if I say 10 raised to 5, how many zeros will be there? 10 raised to 5, how many zeros? It is 5 zeros. Okay, when you say 10 raised to 5, it will have 5 zeros. Now, simple thing, see here, if I write 1 divided by 10, okay, or let us take 2 divided by 10. First, see, understand this easy method I'm teaching you. Okay. But only when it is divided by 10, we can use this method. Fine? Yeah. Now we have an example, 2 divided by 10. So 2 divided by 10 when we have, write the numerator as it is. Okay. In the denominator, check how many zeros are there. We have 1 0. So from right to left, after one digit, you have to put the decimal point. That means after 2, you put a decimal point and put a 0 here. Suppose, for example, one more example I'll take. 3 divided by 100. Then what we do? We will write the numerator as it is. How many zeros are there? 2 zeros are there, correct? And we have only 1 digit in the numerator. So not to the right side, we have to put a 0 to the left side. Okay?
Understood.
So 2 digits you got? Put a decimal point and 0. Understood this?
Yes, ma'am. Ma'am, for the
So
first
same
one will
technique we'll
be
use here. Same technique we will use
yes.
here. So 416. So how many numbers we had? 3 digits we have. 1, 2, 3. We want 5 digits. 3, 4, 5. Then put the decimal point 0. So this is your answer. Got it?
Yes, ma'am.
Yeah. Now, the second question. Second one was a terminating decimal, right? Second one was
Yes,
terminating or
ma'am. It is
non-terminating?
terminated.
Terminating, yeah.
Terminated.
Can you tell me the number? I think 17 by 8. So 17 by
Yes,
8
ma'am.
is written as 17 divided by 2 raised to 3. Then we will multiply it with 5 raised to 3 into 5 raised to 3 in the numerator. So 17 into 5 raised to 3 is 125. Correct? 25 into 5, 125. Yes. And this can be written as 10 raised to 3. Now, how much is 17 into 125? Tell me. Harshit, if you finish your calculation, wait. I want the others to answer now. Okay?
Okay, ma'am.
The other two are just copying. They're not doing.
Ma'am, it's 2125 by 10 power 3.
2, 1,
25.
25.
2, 5. Okay. Divided by 10 raised to 3. So now write the numerator as it is 2, 1, 2, 5. Now, after how many numbers? 10 raised to 3 means how many zeros are there?
3.
3 zeros. So after 3 digits, 1, 2, 3. So it is 2.125. Did you get the same answer, Harshit?
Yes, ma'am. Yes,
Okay,
ma'am.
good. Shreya, which is the next question I have to take? Can you tell me the question?
$75 divided by 1,600.
Question number?
75.
Arey yaar. Question number? 1, 2,
Third
3,
one.
4. Third one? I think
Yes.
third one was non-terminating.
Yes, ma'am.
The
It
third
is
one is
non-terminating.
non-terminating. Question number 4.
Fourth
15
one.
divided by 1,600. Question number 4 is how much? 15 divided by 15. 15 divided by 1600. So this one, what did we get it as? Divided by how much we got? 2 raised
2
to
raised to 6.
hmm?
And then 5 raised to 2.
5 raised to 2 you got. Okay, fine. So now we have to make the exponent same. So what should we multiply it with? So this 5 raised to 2 what we have, we'll make it 5 raised to 6. So if I have to make it 5 raised to 6, then what should I do? You remember this?
You have to
A
multiply
raised
5
to
with 3.
m whole raised to n is equal to a raised to m whole raised to n is equal
AMN.
to a raised to m into n. Correct? Now I have to multiply this with some number. How much?
3.
3. So what will be there in the numerator now? In the numerator, we will take 15 into 5 raised to 3 divided by 2 raised to 6 into 5 raised to 6. Got it? So it is 15 into 125 divided by 10 raised to 6. So how much is this? 15 into 125.
Should I tell?
Yes.
Yes, ma'am. Ma'am, it's 187. Yeah, it's 187, sir.
1875. Okay. Divided by 10 raised to 6. 1875. 1, 2, 3, 4, 5, 6. Into the decimal 0. This is your answer. Is it correct, children? Answer? Just check in your textbook. I have only a E textbook.
Yes, ma'am, it is correct.
Okay.
Fifth one is non-terminating.
Fifth one is non-terminating. So the other questions, will you take it as homework?
Yes, ma'am.
We'll go to question number 3. Fine. Shreya?
Yes, ma'am.
Yes.
Okay. So we'll go to the next one. The following real numbers have decimal expansions. Array, it's already 6:23. I didn't see the time. What to do? Okay. The following
Ma'am, we
real
can do
numbers
this
have,
question.
yeah, we'll finish this question. Okay. The following real numbers have decimal expansions as shown below. In each case, decide whether they are rational or not. If they are rational and of the form P and Q, you say about the prime factorization. What is the question? Something I've missed, I think. Okay. So we have to tell whether Q is in the form of 2 raised to n, 5 raised to m. Correct? And we have to prove whether they are rational or not. Okay. Now, first question. First question, it is a terminating decimal expansion. Correct? Now,
Yes,
since it is
ma'am.
a terminating decimal expansion, it is a rational number. So if it is a rational number, then Q will be in the form of 2 raised to n, 5 raised to m. Okay? So write the answer like this. Since this number has terminating decimal expansion, for the first one, since this number has terminating decimal expansion, it is a rational number. It is a rational number of the form P by Q of the form P by Q, and Q is of the form, and Q is of the form 2 raised to n into 5 raised to m. Okay. Next, second one. It is non-terminating but recurring. Correct? Non-terminating but recurring. Is it recurring?
No, ma'am.
No. It is not recurring.
It's non-repeating.
It is non-recurring, non-repeating. Yes, correct. So here you will write the decimal expansion is non-terminating, non-recurring. The decimal expansion is non-terminating, non-recurring. Therefore, the given number is, which type of number it is now?
Irrational.
Irrational. The third one,
Ma'am, it is correct.
Non-terminating but recurring.
Yes, ma'am.
Correct?
And it has the factors 2 and 5.
Huh. It is non-terminating and recurring. So how you wrote answer for the first one, in the same way here also you will write. You will say it is non-terminating and recurring. Then the rest is all same. You can write it in the form of P by Q, where Q is in the form of 2 raised to n, 5 raised to m. Okay? Done? Okay then. So next question, fourth question we will do. Okay. So only 3 questions you have.
Yes, ma'am. The chapter is
So we
done.
completed real numbers. So next, I think I'll be uploading one assignment in the app. Okay. So go through that. Write your assignment. And I want you people to upload the assignment in PDF format only. If you do it in
In
Word
that app
format,
only,
I
ma'am.
will, yeah, in the app only you can upload. Okay.
Okay,
If you
ma'am.
do it in the Word format, I'll not be able to do the correction. Whenever I give a test also, I want you to write the test and then take a photo and convert into PDF. I think you'll have PDF scanner or something in your phone.
Ma'am, where,
Just
like, when you will give the assignment? Like today only?
today or tomorrow I'll be uploading.
Okay, ma'am.
Okay. So those assignments or any test also when it is given, I want you people to upload it in the form of PDF only. You will get the corrected
Okay, ma'am.
papers also. I'll give you the corrected papers also. I'll do the correction and give it to you, give the papers to you. Or if you want, I'll upload it in the app so that you people can get it. Okay? Yeah.
Okay, ma'am.
Yes, children. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Bye, ma'am.
Okay, bye-bye.